This is our statistically significant mini project 2 by Team 7.
When looking at a day in the life of a mechanical engineer, specifically one that works on producing a product, mechanical engineers will have to generate multiple designs and design processes to fit the constraints made by concept generation. They will use specific skills such as math, applied physics, component manipulation, and material mechanics. Mechanical engineers will make multiple designs and then test each design for performance, looking for flaws and weak points in a design, then redesigning the model until there is a final product that meets all requirements.
Life of a manufacturing engineer. One who works in the processes of manufacturing a product will take the time to look over the fabrication processes and work for efficiency in cost and time. They specifically have a skill set and knowledge of geometric dimensioning and tolerancing, machine tool manipulation, CAD and production software, and process knowledge. Their task on the day-to-day is to make sure that a design can be interpreted in layman's terms for technicians as well as if a design can be manufactured. They will work with the flow of a whole production line and make sure there is enough supplies and the tools to perform at optimal efficiency.
For a mechanical engineer, statistical data can be very useful when testing a product. With many iterations of the test, it is important to look at the statistics for how consistently a product performs within its design constraints. It is also important to know material or design strengths and weaknesses in certain areas, allowing mechanical engineers to choose the best material or design to use. Statistical analysis of data collected from tests will give the mechanical engineers another avenue to analyze their design.
In an example of an assembly line, the use of statistical analysis of data for manufacturing engineers is that it will allow them to determine the strengths and weaknesses. From there, a manufacturing engineer will solve for a solution to strengthen these flaws, allowing the assembly line to work as efficient as possible.
Mechanical and manufacturing engineers cooperate in multiple grand challenges of engineering. The first two challenges that incorporate both mechanical and manufacturing engineering include making solar energy more economical and providing access to clean water.
For challenges that focus more on improving society as a whole, we found that mechanical and manufacturing engineers can pivot their focus on restoring and improving urban infrastructure, as well as engineering the tools of science and discovery.
In summary, for our 4 grand challenges of engineering, mechanical and manufacturing engineers will be working closely together. A mechanical engineer can create multiple designs that could be an ideal solution to a problem, but a manufacturing engineer has to be there to keep them in check. This is because not all designs of a product can be manufactured or manufactured at a realistic cost.